The inventory worksheet, continuous and periodic review system. Okay, so this set of questions is pretty cool in that they're not complicated, but they do delve into some basic fundamentals regarding continuous review, aka Q systems, and P systems, aka periodic review systems. So let's look at question number 1. So from the time an order is placed, it takes 1 day to arrive. So the lead time is 1 day. Gotcha. We know that daily demand averages 70 units, so D bar is 70 units. How much inventory should we plan to have on hand when the order is placed? This is referred to as the order point. Now, this is important because, yeah, okay, so we read it and we go, okay, that's fine. To think about when you go get the exam, right, that stuff in brackets is not going to be there. So we need to understand how much inventory should we plan to have on hand when the order is placed. That's another way of asking for what's the reorder point. So yeah, the reorder point is easy to calculate. You go D bar L times, you go D bar times by L, 70 times 1, you get 70. That's easy, right? But understanding that the question, that's what that question is asking for when you see how much inventory should we plan to have on hand when an order is placed. And the calculation is simple, but understanding what it is that the question is asking, that's not always as simple until we start to get used to how the lingo works. In the above question, what should we know? What if we know the standard deviation demand to be sigma d subscript d's to be 10 units? Okay, well now we could work with something, right? We've sort of got a starting point. Now, we can't calculate safety stock just yet. We understand that with the variability in demand, we want to have some safety stock, right, to meet some unforeseen or unexpected, unexpected increase in demand. This tells us we want to have some safety stock. Without knowing what the cycle service level is, we don't know how much safety stock. So standard deviation of daily demand or variability in demand tells us we want to have safety stock, and then we need to know what cycle service level is in order to determine how much that safety stock should be. Okay. Question number 3. Average daily demand is 10 units. The standard deviation of daily demand is 4 units, and the lead time is 5 days. What is the average and standard deviation of demand during the lead time, respectively? Okay, so demand during the lead time, okay, sigma DLT. It's almost like a sandwich, right? And we know from our formulas that is sigma D times by the square root of L. So far, so good. Which equals to 4 times by the square root of 5, and that's 8.944. Okay, so that part's not so bad, right? We just understand this is what they're asking for when you see demand during the lead time, respectively. What's the average demand now? That's just D bar L. Right? Simply 10 times by 5, and that's 50. So the whole idea here is not that the calculation is very difficult. The calculation is quite simple. But just getting used to connecting what exactly is being asked with the calculations that we know. Let's move it on to number 4. Using the above case, okay, should the reorder point be, what should the reorder point be if we want to ensure that we will not stock out during the lead time with 90% certainty? Okay, so now we know that the cycle service level is 90% or 0.9. Now we're all set. We can now plug all that in and get our safety stock. To do that, we use Excel. Right? We know we're going to calculate a Z-score, so we bring in Excel. Quick little sheet in Excel, real easy to do. We've done this before. We go norm.s. Oops, not a comma. .inv, and then the cycle service level 0.9, and then bracket. And we get 1.28, and a whole bunch of other stuff there, right? Okay, so our safety stock goes to 1.28, and you can go as many digits as you want. We're going to be rounding it up anyway, so it doesn't really, probably not necessarily worthwhile to get too crazy with the decimal spots. And in this case, we get 11.4487. We round it up to 12. Okay, that's the safety stock now. We're not done yet. Reorder point is that 50, right? The D bar L. Had that from before. Plus the 12, and that equals to the 62. Okay. Bye-bye, Excel. Okay, so not so bad, right? We just we keep the components. We start looking for the components. We use Excel, right? Excel, very useful for the table lookup for those Z scores. Ha, awesome. All right, question number 5. How much inventory is expected to be on hand when the order arrives in 5 days? Well, you go, what? And what's the formula for that? I'm not sure. There is no formula. We already know it. It's D bar L, right? Whatever. When we start to say what's expected, that means if demand is as it normally is, expected is like an average. Right? If demand is as it normally is, then we would expect to sell 50 items and to have 12 items left over. Right? The safety stock doesn't get touched. In 5 days, we expect to sell 10 units per day. Over 5 days, we expect to sell 50 units. And at the end of that 5 days, we'd expect to have safety stock still remaining. Okay. Question number 6, true or false? Demand has variability, lead time is 0. Would safety stock be required? Has variability, lead time is 0. Well, think about the formula. If it says Z, sigma D times the square root of L, and L is 0, mathematically, it suggests no. Right? Conceptually, it would also suggest no. And that's because even though the demand changes, we can instantly get stock. So if someone orders something and we didn't expect that order, we can instantly get the stock to sell to them. Okay. Demand has no variability. Lead time is positive, but has no variability. Okay. Again, no variability. Mathematically, the safety stock formula becomes 0. But why do we have safety stock? We have safety stock to meet unexpected demand or changes in demand. If there are no changes in demand, then there's no need for safety stock. Demand has no variability, lead time is positive, and lead time has variability. Okay, same as above, right? The wrinkle in that, we haven't really dealt with lead time variability, but again, if demand has no variability, we basically stop there. Same discussion as we had with bullet 2. Demand has variability, okay, but can be perfectly forecasted. Lead time is positive and has variability that can also be perfectly forecasted. Okay, so essentially what's that telling us is, yes, demand changes, but we know what the change is at any moment. Do we need safety stock? No, because if we can forecast what demand will be for the next 5 days perfectly, then there's no unforeseen bump up in demand for us to have to deal with. Right? So, pretty tricky. Right? Some pretty good conceptual stuff in question number 6. Okay, let's talk about question number 7. So the Petville Veterinary Clinic uses a inventory system for their dog food that resembles a two-bin system. Inventory arrives from the supplier. Petville places a predetermined amount in a storeroom, and the remaining inventory is placed on a shelf in the customer sales area. So we've talked about this two-bin system before. Thus, when the inventory and the customer sales run out, Petville knows it's time to place an order with the supplier. At this time, they replenish the shelf in the customer sales area with the inventory from the storeroom, which has been calculated to be enough to ensure that the probability of stocking out during the 4 days as they wait for the order is 5%. So we have essentially a cycle service level of 95%. Okay, so we meet customer demand 95% of the time, which means we don't 5% of the time. For this question, assume that daily sales for Smiley Dog brand dog food averages 20 units, standard deviation of 4. How many units of Smiley Dog food should be in the storeroom when they receive an order from their supplier? Okay. Okay, so should be put in the storeroom when they receive an order from their supplier. And this little clunky worded question we are essentially asking for in part A is, what's that reorder point? Okay. So the elements of the reorder point is d bar L plus Z sigma D over the square root of L. D bar, we see that R is equal to 20. Lead time is 4. Z score we'll look up in just a smidgen second here. Standard deviation is also 4. Lead time is 4. 4 is the number of the day. Okay, so let's bring back Excel in here. Okay. And I could just change my existing norms dist formula and change that to 95%. And now I get about 1.644, 1.645, that kind of thing. 645. And eventually we get R is equal to 80 plus our safety stock, which is 13.16. We know that rounds up to 14. So that means that R is roughly 94 units. Okay. Now the next cool question is part B. And part B is, what is the average cycle service level in this case, assuming the same rounding in A? So when we found this, we set a minimum of 95%. What is the actual number? Oh, that's kind of cool, right? So what we're going to work out is go a little bit backwards. So we have 94 equals to 80 plus Z 4 times by the square root of 4. So this requires us to do just a little bit of working backwards. Okay. In this case, we get a Z is equal to about, what, 1.75. And now we're going to use our Excel again. So we roll Excel back in. And this time we're going to use norm.s.dist. Or I'll call it, sometimes I go norms dist, because that's sort of the old way it used to be. So I apologize for that. We have our Z score. Okay. We'll always click cumulative, which is 1. Okay, we don't really care about the PDF for a normal distribution. And what do we get? 95.99%. Okay, so our actual cycle service level is 95.99%. So almost 96%. So we're, because of the rounding, we're a little bit higher than the minimum requirement. Okay, that's good, because it is a minimum requirement. All right. continuing on with our themes, let's just talk a little bit about periodic review system. Periodic review system, so how is it different from a continuous review system? That kind of stuff, that's all definitional. Look it up. You can kind of see how it's differently. Two biggest questions is the how much and the when, right? So think about that. Why does order quantity vary in a P system? Well, because demand varies. Right? We do a regular review, but that regular review is done certain time intervals. But how much demand actually was in any given time interval can be different from interval to interval. This, just focus on the two types of costs that we care about. Target level is chosen. Start thinking about what does that formula for the target level look like, right? So that target level. So the formula tells us the story, and is like a picture's worth 1,000 words. So when we look at the formula, it's really telling us what's going on here. So if I look at, let's write out that formula. So if I look at that formula, it's sort of telling me, well, what's driving the target level? Well, it depends on how long between reviews, so P. Depends on the lead time. Depends on variability in demand. Depends on cycle service levels, right? So these issues are all important. Now, how much is ordered, right? The order amount, well, that's T minus IP, right? So it depends on the inventory position, the order size. So there's lots of issues that we have to consider that can impact our order size and our target level of inventory. Okay? So often the easiest way to deal with these situations is to look at the formula. The formula is not just for calculations. Equations and formulas exist to describe relationships. They're just a very compact version of that, which makes them very efficient. Okay, so question number 8. A store uses a periodic review system to manage their stock of potato chips. Every Monday they check stock levels and place an order which will arrive on Wednesday. All right, there's our first piece of information. Every Monday, means that period is 7 days, right? That's every Monday. Lead time is 2 days because we check it on Monday, order Monday, get it on Wednesday. Crazy cooperatives sell an average of 6 bags per day. So D bar equals 6 bags per day. Someday I'll learn how to write. Standard deviation 2.1 bags. Okay, standard deviation 2.1 bags. Cool. Further assume they wish to ensure the probability of stocking out during a weekly cycle is 10% or less. So that means cycle service levels. That's how often they meet demand will be 0.9. Okay, so if we want to stock out 10% of the time, it means we have to meet customer demand 90% of the time. And if on Monday, March 5th, they have 14 bags on hand, inventory position equals to 14. How much should they order? So we're looking at T minus IP. And that's what we're interested in. So we know what IP is. That's the 14. Okay, so that's no problem. Now let's find out what the T is. So we bring everybody together. Using our formula for T that we were just discussing. And so we have 6, 7 plus 2, plus, we'll fill in the Z in a sec because we'll bring in our good friend Excel. And then standard deviation, 2.1, and the square root of 7 plus 2. Okay. Let's bring in our Excel again. Looking for another Z-score, except instead of 95, it's 90. And we've got 1.28. Used that one before. You pull Excel away. Okay. Target inventory, and we'll get 54 plus 8.064. We know we have to round up all the time, so it becomes roughly 63 units. Okay, remember, we're always rounding up, otherwise we'll be taking that cycle service level below 90%, and we want it 90% or higher. The 90% is the minimum. Now, that's not our order size, and so to get our order size, T minus IP, which is equals to 63 minus 14 equals to 49 bags. That's how much our order size is. Okay, I commented earlier, it's really easy to miss that last step. Okay, really easy. Okay, question number 9. Typical demand for widget is 1,000 per year. Okay, each widget costs $10. The rate for inventory costs is 25% per year. Ooh, this is sounding like EOQ-ish. What the company wishes to implement a periodic review system where they check inventory and place an order every P days. What should P be? Okay, so one of the ways to choose P is we could find the time between order, the TBO. Okay, and we know that TBO equals to, and now I get acronym heavy here, the EOQ over the D. Oh my goodness, right? Now we do have D. We do have D. That was at 1,000 per year. We want TBO. We just need the EOQ now. Okay, so let's EOQ equals to 2, and then times by demand, which was 1,000 bags. And what's our order cost is 30. Okay, cool. And then we divide by our holding cost, which is 25% of the widget cost. So I can kind of do that in my head and get $2.50. I don't want to forget to square root it. Okay. And then out pops an answer, and it's roughly 155. Again, EOQ is going to be in an integer. In fact, it's going to be a whole number. It's not going to even be a negative number at all. Okay, so now we have our EOQ. Now, next step, last step, ramp it up, is we find our TBO, which is that 155 over 1,000, which is equals 0.155 years. Nobody really talks that way, so if we times that by, let's say, 365, we get about 56.575 days, okay, or about 57 days. Now, you know, if it's a big concern, you could easily just say, hey, about every 2 months. Right? So some flexibility there, depending on operational ease. Okay. Number 10. Number 10, number 10, number 10. Okay. A rack jobber, that's just somebody goes around selling stuff. Old school word. Rack jobber representing maps, travels to gas stations and convenience stores on a regular weekly route. Regular weekly route. Okay, so means periodic is 1 week. Okay, gotcha. We read further. Average demand for these is 21 per week. Okay, so it looks like weekly is our, where the data is gathered. 21 per week. Standard deviation per week, 4.5. Okay. Wants to ensure 92% service rate. So cycle service level, 0.925. On a day where there are 5 maps remaining, so inventory position is 5. How many should they add to the stock? Okay, so basically the order size. And how many maps should the representatives expect to see in stock when they arrive next week? Okay, Awesome. Now we doesn't say periodic review per se, but coming every week kind of tells us that that's when the stock is being reviewed. And so when there's a set time for that stock review or that inventory review, tells us that it's a periodic review system working on here. Now it looks like the tricky part is lead time. He goes into the truck or goes into the car or whatever and grabs some items. So that's an interesting twist. Lead time technically 0. Okay, cool. And that's not uncommon. That's typical in those days when people used to go around selling stuff. Often it was in the van, and they just kind of count up how many you needed. Whatever you needed, you go into the van. Your Frito-Lay person works in a very similar way too sometimes. Is they adjust for, they go to the 7-Eleven. Sometimes there's some flexibility in the size of the order. They look and see how much you need. The gasoline delivery person works similarly as well. Okay, so we have T. We want to find how many should they add to the stock. So we need to find the order size, and the first step to finding the order size is finding the target level of inventory. And so we have our D bar times by P plus. So it's 1. Everything's on a 1 week basis. So 1 plus 0 plus Z, which we will look up, 4.5. And then P plus L, again, is that 1 plus 0. Okay, so let's bring in our Excel, because we have a little slightly different cycle service level. And instead of 0.9, let's put in 0.925. And get a 1.44. Okay, so let's use 1.44. And now we just plug T through. We get 21 plus 6.48. We're going to round that up. So target inventory is 28. Order size is T minus IP. So it's a 28 minus 5, which means we need 23 maps. And that's our order size. Now, when the representatives comes back, what would they expect? Key word there is expect. That means sales are as per average, which means sales are 21. You have 28, and it becomes just the amount of the safety stock. So we would expect to see 7 maps still there next week. Now, clearly last week we saw 5, so demand was a little bit higher than expected, right? Assuming that everything was done correctly the week before. And so it looks like they sold 23 maps last week. They expected to only sell 21, so sales were above expectations. But if they are at expectations, that means we sell the 21, we had the 28, what's left over? The 7. What is the 7? The safety stock. And question 11, we have been determining safety stock given a desired cycle service level, probability meeting all demand during the lead time. But how do we decide the cycle service level? Now there is the big question, right? And that's a very open-ended question. Depends on the business that we're in, depends on cost of carrying the inventory. All those issues that we talked about with demands for small inventories and large inventories are all at play in deciding how much or what that cycle service level should be, because that's driving, if we have more inventory, it means there's a bigger cost to that inventory. Okay, so all those issues related to holding costs to play into this as well. It plays into the kind of business that we're in, right? Remember, our operations strategy and our business strategy must align with each other. So it's very open, very cool question in number 11. Okay, thank you.